with that, the tie-in, I think it is perfect tie-in. Bill, if you want to go ahead and share your screen and give a brief introduction, if you might, please, sir.
Okay, let me see if I can share my screen. Hopefully everybody can hear me.
I hear you just fine.
Let's see. Host disabled, participant screen sharing is the message I'm getting.
Oh. There you go. Sorry about that. I thought I'd already made you co-host.
Okay. All right. Hopefully everybody can see my screen at this point.
Yeah.
So, brief introduction. Thank you, Amanda, for asking me to present today. I'm considered the hybrid winter wheat breeder for BASF, and so I guess Amanda thought this would be a good opportunity to tell you guys a little bit about hybrid wheat and what we're trying to do relative to hybrid wheat, because it is pretty exciting work, I think. So, and so let me get started with this presentation then. Here, let's see. Okay, hopefully you can see it
Perfect.
as a presentation at this point. So this is showing you just the crops that we are involved with as far as BASF is concerned. We're not just working on wheat, but we're also working on canola, sunflower, soybean, corn, cotton, some fruit and vegetable crops, and also rice for Asia. And most of these crops, I think, came over in the transfer as we were acquired. Many of you probably realize this, but back in 2018, we were actually acquired from Bayer by BASF. Bayer was interested and, of course, went ahead and acquired Monsanto and the Department of Justice in the United States, and similar agencies across the globe, were saying you can't have a monopoly to Bayer, and so we had to be sold off and were acquired by BASF. I'm going to focus on wheat, of course, today because that's my specialty, my area, but just to realize that we also are working on other crops as well. So you might ask yourself, why are we interested in hybrid wheat? And there's a number of different reasons, and these are the reasons from, particularly from the corporate point of view, why we're interested in hybrid wheat. One is that it's pretty evident that global warming is strongly affecting wheat yields in a negative fashion across the globe. In fact, it looks here from this graph that maybe only, not quite the same negative effect in the United States, but certainly across the globe, there's been a pretty consistent effect, negative effect of global warming on wheat yields. So there's the idea that hybrid wheat might help from that perspective. When we think of a hybrid crop, we always think about the heterosis. That's the term we use for the advantage of the hybrid over any kind of inbred, purebred line. In the case of wheat, it's pretty widely been shown that we can expect anywhere from a 5 to 10 to even somewhere in the 15 to 20% increase in yield over pure line. But I would say on average, anything from 5 to 10% seems to be the more typical type of advantage we see for the hybrid over its best parent or an inbred line. And so that's another reason. Let me just say, hopefully there'll be time for questions at the end, but if you If I drop off or anything, please let me know. And if you have a quick question, I can try to answer certainly as I go forward here. The other perspective from a corporate perspective of why we're interested in wheat in particular is because, especially in the US, of course, we realize that there's a huge acreage production of wheat, especially in the winter wheat area, yet the demand from a commercial side doesn't seem to be being met very well. And so from the corporate point of view, they say that the acreage and the seed market really are not in synchronization. So some other opportunities here with hybrid wheat is, most of you probably realize this. I know Brett Carver was on this call in this conference, and certainly I'm sure he recognizes that technology really hasn't penetrated the wheat crop quite as much as some other crops that breeders have dealt with over the years. And so we think there's a lot of opportunity for new technology to impact especially hybrid wheat development. It's largely, of course, been inbred at this particular point in time as far as what breeders have worked on. And so there's really untapped potential, at least the company feels that way, from the standpoint of developing the hybrids. BASF, it was true when I was with Bayer, but now with BASF, it's also true. But there's a large crop protection business, and there's no secret that BASF wants to combine the crop protection business and some of the aspects we can bring from that, along with the hybrid platform to provide the very best package to the farmers. As I mentioned just previously, there's a relatively large acreage for wheat, but a small commercial seed market to meet the demand for that large acreage. So there's opportunity there. And of course, wheat is a key crop for global agriculture and food security. I don't think that the acreage is necessarily going to go down significantly from the standpoint of there's always going to be some demand for wheat and for global food security reasons. So relative to what we're doing with hybrid wheat and BASF, we think we've made a lot of progress at this point, and I'll talk about some of the details of this as we go forward through the presentation. But just to highlight some of the aspects where we think we've made some progress. We think the hybridization system, we're using the CMS, or cytoplasmic male sterility system, for actually producing the hybrid, the commercial hybrid, and we think we're on track for doing that. We achieved what we called technical proof of concept, or TPOC, back in 2015, and now we're on track for the commercial proof of concept within the company. And so there are certain milestones and achievements that we have to meet to stay on track for that, and we have been on track to do that within the company. We're on track for converting our males and our female lines, both from a standpoint of converting the R lines for restoration and the female lines for to transfer the CMS background to the females. We're also on track for introgressing certain traits that we want to have into our hybrids. Talk about some of these disease type of things that we've been working on, as well as some other traits a little bit later in the presentation. We're moving from collaboration on BASF to BASF developed materials. So what that means is Initially, we entered into a lot of collaborations with universities to acquire germplasms to start the program. This was when we were actually Bayer for the most part. And now we're actually developing the materials within our own breeding programs, acquiring less and less germplasm from outside of BASF. We have really demonstrated some promising performance of our first generation hybrids, so that gives us a lot of confidence and hope going forward as we're developing our hybrids. We also see some emerging heterotic groups and working on genomic selection methods to develop and define those heterotic groups. So when you talk about hybrids, you want to identify different groups that will make the different parents will come out of to give you the maximum heterosis possible. And so we think we're on track to continue to define those groups. The launch window that we're looking for the first commercialization, this is a question we almost always get asked. And I would say we don't like to say specific dates because things can change rather rapidly in this business. And so we're targeting the mid-2020s as a launch window for our first commercial hybrids. We have target markets in Europe, the Ukraine, and also in North America by the mid-2020s. Several seed production systems are in development relative to hybrid seed production, and those continue to be defined as well. So this is where our different breeding stations and different operations are around the globe. So I just can highlight for spring wheat, we have a group operating out of Saskatoon in Canada at the Pike Lake breeding station. We have a Fargo breeding station, or Sabin, Minnesota, right across the border from Fargo. And that's operated with my colleague in charge there, David Bonnet, at the Fargo. Myself and several of my colleagues are located at Lincoln, Nebraska here, and we work on winter wheat here in the US, hard winter wheat. Then we also have a group in Ghent, Belgium. These are mainly the folks working on our doing our molecular breeding work and working on the marker development and application of markers to our lines in Ghent. We also have a breeding station in Gotterdsleben, Germany, which used to be East Germany. We also have a breeding station in the Ukraine. We have a group at Milly-la-Forêt. This is actually an important group because they do a lot of doubled haploid work at Milly-la-Forêt in France. And we even have a group in Horsham, Australia, working on spring wheat there. They're a little bit late to the game as far as working on the hybrids there. They've still been developing lines there at the Australian station. So just to give you an idea of who is at our station, because I'm mainly talking about what we're doing in our winter wheat area and in the area of targeting Kansas, Oklahoma, as well as Nebraska. So we have Sally Claysholt, who is our North American lead for breeding. We have Rima Thapa and Sue Latshaw, who are our line breeders, working on the female line development, as well as the male line development for the hybrids. We also have Hugo Gomez, who is considered our discovery breeder at our station. He works on developing unique germplasm, things like what you might think of as pre-breeding activities to develop various unique traits within our lines that are handed over to our breeders. Things like hybrid enabling traits, better anther extrusion, better ability to cross or outcross. These are the kind of things that Hugo is working on. We also work very closely with our pathology and use quality group, and this happens to be Pravin Gautam is our pathologist at the location, and Rhett Kaufman is our serial scientist who came originally from the USDA in Manhattan, Kansas. These guys, of course, help us evaluate our hybrids and parents for disease and insect resistance. In the case of Pravin, case of Rhett, he's helping us evaluate our hybrids and parents for milling and baking characteristics. I should have added on to this slide, that kind of thing. So are people still following along as I'm going, or can you hear me okay?
Yes, sir. Everything's
Yes.
just fine.
Okay, great. Okay, so since we're into December now, and we're getting a little bit closer to the Christmas holiday, I like to think of the activities that we do in our breeding program, our hybrid breeding program, as very much like a Christmas carol from this standpoint. Every time I talk about our materials this way or our activities this way, my boss says, "Well, these are friendly ghosts. They're not adverse ghosts in terms of what we're trying to do." So anyway, we have these three activities going on every year in our hybrid breeding. And the first one is what I call the ghost of Christmas yet to come, because every year we have to make new test crosses, and we're using a chemical hybridizing agent to make new test crosses to test hybrids in our yield trials. And so this is the ghost of Christmas yet to come, because we can't test those until we make them. And so they're hybrids that are yet to be tested in following years. We're always hoping to make enough seed in our initial test cross, though, to test it for a first year, and then also for another second year of testing around the region. So the first year of testing in yield trials is what I call the ghost of Christmas present, because those will be the hybrids that we test this year, for example, as far as winter wheat is concerned. And then the second year of testing, things that do well, of course, in the first year of testing will get advanced to a second year of testing, and that's what I would call the ghost of Christmas past, because again, it's already been tested for 1 year. We know that they've done well, and we hope that they do well again in a second year before we can consider them for possible entering the commercial pipeline for development as hybrids. So most of you probably know this, but when you talk about hybrids, what we really try to identify in the hybrid scheme of things are things related to what we call, from a genetic standpoint, general combining ability of the parents and specific combining ability of the parents. So GCA and SCA for short. And so I like to think about this as sort of a narrowing type of activity of the funnel in the breeding program. So at first we have all these materials to look at in the test cross nursery, all the parents that we have to identify and pick out the very best parents of that. And so first we're looking for all the very best general combining ability parents that we can find in the large group that we test in the test cross nursery. And then eventually we're narrowing that down to certain specific combinations between the very best general combining ability parents to identify the best specific combining ability parents for the hybrid combination that will go into the commercial stream. And so to explain general combining ability versus specific combining ability just a little bit better here, is that if we look at crosses, so this is a what we call a diallel cross between a group of 10 parents here on one side and a group of 10 parents here on the other side. So you can consider maybe these males on the top, these females on the column side here. When we make those crosses, we can actually look at the average performance of those lines in this column here, for example. So this is the average performance of those lines, theoretical performance, let's say for yield of these lines in the column. All the way here on the right column is their average performance as they're crossed to all these ones on the top. And you can see that there's two here that tend to have a better average performance than any of these other ones. I've highlighted those two in red here. Those two we would call high general combining ability parents, because whatever they're bringing to the table, they bring it to the table for yield in a positive way across all those, in general, across all those parents, all those male parents, if we're calling those males there, in their average performance. However, we can also pick out sort of specific combinations. So here's a specific combination between 2 and 4 here, which is very much higher in its performance than any other combinations here, and the very same combination of only in the reciprocal type of cross way is performing very well as well. So that's what we're talking about when we talk about specific combining ability, that we're finding very nice specific combinations after we find good general combining ability types. So we don't all, of course, only deal with yield, looking at general combining ability and specific combining ability, but we also need to look at disease. And again, this is where the work of Prove and Gautam comes into play. And so here's an actual, I had to take out what these parents actually are because the business won't allow me to show those for various proprietary reasons, but just to show you the kind of information that I receive from our pathologists when I'm looking at this. So we're screening for things like Fusarium head blight resistance or scab resistance, yellow rust or stripe rust resistance, leaf rust resistance, wheat streak mosaic virus resistance, and also barley yellow dwarf virus resistance, among other things. These are just a few of the main diseases that we're screening for. And we get a general type of rating of these, everything from moderate, very resistant, moderately resistant, resistant, moderately resistant, and so forth down the line, all the way to very susceptible. And obviously, we want to look for parents that combine good resistance as much as possible across the various traits that we're looking for here. And so here's a couple parents, parent 6 here and 10, that are actually pretty good across all of these. Not good for everything, but it's very rare that you find a parent that's going to be very good for every disease that you're trying to screen for, of course. We do a very similar type of thing when we're looking at quality. So we look at the parents for quality, and then we look at what they look like when they're combined in the hybrid. And so when I talk to Rhett Kaufman, when we look at the mixographs, and so I'm sure Brett is very familiar with looking at these kind of mixograph curves. And so what Rhett always tells me is we don't want any mosquito type curves, and those are these type of curves right here, because you have a rapid rise as far as the mixed tolerance is concerned, and then a breakdown of the dough very rapidly and quickly to give you this narrow beak of the mosquito here. So in combinations, both in the parents and in combinations, we don't want any kind of mosquitoes in in our breeding program as far as hybrids are concerned. And so what you can see here is if we look at male 2 here, it seems to be a worse male than some of these other males for actually producing the hybrids from a quality standpoint, because you can see that, you know, in these 3 cases, we see those kind of mosquito type of graphs. And you can also see it on the female side. It looks like female 3 is probably across all these different females, giving us a similar, more mosquito type of graph than the other females. So this brings me to something I want to point out to you, a strategy that's really available to hybrid breeders. And I didn't really appreciate this so much until I became a hybrid breeder, as opposed to an inbred pure line breeder, as I was in my past life as a breeder at universities. But what you can really do as a breeder more easily in a hybrid type situation is mix and match your parents so that you can perhaps mask the expression of a poor trait with the opposite parent. You can also really maximize the stacking of traits in your hybrid, because again, the end product is actually the combination of 2 different parents, as opposed to a pure line inbred variety that's released like out of a lot of the varieties released out of Dr. Carver's program. So for example, we could take parent 10 here in terms of the disease resistance that I was showing you, cross it with parent 2, which is, you know, much more susceptible to many of these, and we might be able to get a more resistant hybrid out of that. And so sort of recover this parent 2 from a disease standpoint, particularly if parent 2 is giving us a good heterosis for yield in combination with parent 10. Similarly, from a quality standpoint, I don't know if you saw it in that, slide previously, but if we would have combined female 4 with male 2, which was very bad, it actually gives us a pretty good hybrid for quality. And so we can make that combination maybe to get a good quality hybrid anyway. So I just wanted to jump in briefly to tell you a little bit more, if you're not familiar with the CMS system, how it works, just to give you a little nuts and primer on this. It's a little bit more complex than hybrid breeding, but you deal with what we call an A line, or the female line. You deal with a B line, or what we call the maintainer line on the male side. And then the final line that you need for the commercial production is called an R line. Okay, and these have different combinations, whether you're talking about the cytoplasm or the nuclear genes that are involved here. So the A line would have the sterile cytoplasm. The sterile cytoplasm comes from a wild wheat that we work with. The nucleus would not have the restore genes for that, because you want this to be male sterile, so you can make the hybrid in the end. But how do you maintain or keep seed of this one going when it's sterile to itself? And so that's where the B line, or the maintainer, comes in to play. It doesn't have any restorer genes itself, but it's got a normal cytoplasm, so it's still going to produce pollen, and that's used to maintain the A line as we go through this process. Then in the end process, you're going to need an R line, something that does have restorer genes in the nucleus. Doesn't matter so much whether the cytoplasm is normal or sterile, because you're going to be crossing this as male, and the female, the cytoplasm is always donated by the female. And so the commercial hybrid actually is combined by using the R line as the male to the A line female, and you get hopefully a fertile hybrid there, or the farmer's not going to be happy with the seed that he or she gets back. I'm going to run out of time, and I want to get to the last couple slides here and keep you guys on time. And so this is just sort of a diagram of something that I just went through. And so if you're more interested in the actual CMS technique and that, you can kind of review this since this is being recorded, everything as well. The things I really want to illustrate, though, that one of the biggest challenges we have is from what we typically call in the cost of goods. And that is one of the things that others have tried hybrid wheat in the past. One of the biggest barriers to actually getting hybrid wheat to work is that from a biological standpoint, wheat is not like corn. And so as you guys realize, I'm sure, corn is cross-pollinated, naturally cross-pollinated. Wheat is not. And so it's very hard to produce hybrid seed with wheat because it's self-pollinated, naturally self-pollinated. Be very nice if we could just lop off the tassel as they do with crews of kids here in Nebraska when they're producing hybrid seed and corn, but we can't do that because the female and male parts, of course, are in the same spike. And so this is one of the biggest problems we have to overcome from the standpoint of producing hybrid wheat. So we do a lot of work to optimize seed to hybrid performance and seed production in what we do. And these things relate to things like female receptivity and seed set on the female. Flower traits are very important to us, relating to pollen production, pollen viability, number of anthers that are produced, the anther extrusion from that standpoint. And so we're trying to optimize hybrid performance in a number of different ways with these various traits, also by management type of techniques, using the kind of things that Amanda talked about in her presentation. One other thing to remember is, and this relates to the business cost of goods, is that, if you're trying to sell hybrid seed, what you'd really like is something that in the production field produces a lot of seed, and then it takes less seed to actually seed the field that the farmer is going to seed for their production. And so you want something that's going to produce a high amount of seed in the production field and take less seed to plant in the actual farmer production. And so this is where the contrast becomes really evident between something like corn versus wheat. So you see corn, on an ear of corn, you probably have around something like 415 seed on an ear of corn. The seeding rate for corn is about 10 to 18 maybe pounds per acre from what I looked up a few years ago. For wheat, you're looking at maybe 25 to 30 seed in a single head of wheat. And it's going to take about 60 to 90 pounds per acre to seed wheat. And so it's just the exact opposite of what you have in the optimal situation of corn for that situation. So I'll conclude my presentation by being optimistic, because we are optimistic and very bullish on hybrid wheat and BASF. And for the reason that there's a lot of technology and innovation that we're able to bring to breeding and development of hybrid wheat that we think is going to make it a good go for us from a commercial standpoint in the not too distant future. I'm not going to go into all detail because I want to keep you guys on time again, but digital breeding aspects, automation of various processes, germplasm enhancement. We're very heavy into using predictive analytics for predicting hybrid performance, for example, parent performance. We're using advanced technologies, double to haploid production, various digital imaging technologies, and then looking at some various predictive and precision breeding technologies. So the take-home message I want to leave you with is that new technologies and innovations really are and can now be applied to developing hybrid wheat. And that's what makes it exciting to us. And I think hopefully, like I said, in the mid 2020s here, we'll be pushing to commercialization with hybrid wheat. And with that, I think that's it. I want to thank you for your interest. And I don't know if we have time for any questions at this point. I might have went a little bit long.
We do. No, we're good. I greatly appreciate your time that you spent with us today. We've got a couple chat questions that came in. The
Okay.
first one, it's a shorter one, so it's easier for me to read. The question comes in as, which is easier to develop, new females or new males?
Yeah, that's a really good question. I think initially I would say it depends on what part of development you're talking about, but I would say initially it's been more difficult for us to develop good males. And the reason for that is because we don't want just one restoration gene in a male. We need more than one restoration gene. And so that's involved our breeders having to stack these our genes. And then they need to track that not only with markers, but they need to also identify, that they have good restoration with the stacked genes phenotypically. And so that's taken a lot of work. I think we're getting close to having good males from that standpoint, but that's been a lot of work. But on the female side, once you have a good R line, it's very easy to maintain that seed because it is self-fertile, of course. It's much harder once you identify good females to maintain the A lines because, you have to have the B line to go along with it, to maintain it. And just from a production standpoint, it's much harder to maintain the female from that standpoint. So, it depends on what part of the development you're talking about. But from the standpoint of stacking the genes and developing the males, I would say they're initially were more harder than the A lines. But from a standpoint of maintaining the A lines, they're much more difficult. So.
Fantastic. We had another question come in from one of our county educators. And he rephrased it so briefly. Are there traits that are less heritable in wheat? He tries to refer back to cattle that there's some traits that are much easierly to transfer with selective breeding. Are there certain traits that are easier or harder to get through with heritability?
Oh yeah, for sure. Of course, in breeding, we always talk about qualitative and quantitative traits, and it's similar, I'm sure, in cattle breeding as well. And so quantitative traits are traits that are usually affected by many different genes, and the environment also influences their expression and much more so than qualitative traits. Qualitative traits are the ones that are more by just a single gene and maybe a dominant gene that's less affected by the environment. And so they're much more easy to deal with. Those are usually, the qualitative traits are usually things like some disease resistance traits and so forth. Unfortunately, the quantitative traits are things that apply to yield, grain yield and so forth. And that's always, of course, the difficulty for breeders to deal with. It does add a new aspect to things. That strategy I talked about, though, how you can combine these traits in a hybrid in a strategy that you don't have available to you generally when you're breeding just a variety, a pure line variety. So
Fascinating. Anybody else have any questions right now before we move into our next speaker? Dr. Berzonsky, thank you very much for your time. I hope you can stick around for the panel in case there's some more questions.